board. I don't want to ping my screen. There we go. All right. All right. So today we're going to be going over mass. And mass is directly related to how fast your car goes. Okay. Mass is related to the weight of your vehicle. Okay. And so they give you the formula: mass is equal to density, which is P, times volume, which is B, or V. Okay. So the less your car weighs, the quicker you can get your car up to full speed, which will mean the faster you can get your car down the track. Okay, and this equation shows that a mass of an object depends on variables called density and volume of an object. All materials have a unique density, and the following table shows they vary a lot. So there are lots of different things here. So like brass is really kind of heavy, and it's got a high tensile strength. If you look down here, balsa is way light, but the tensile strength is not as strong. Okay, but the advantage of balsa is that it is light. Okay, and that's what we like. You can also use basswood, but then your car is going to be heavier and it's going to go down the track a lot slower. Okay, so you want to go back and look at this information here, and you want to, you're definitely going to want to read this whole thing here. Today, I want you to do the mass worksheet, kind of go in there and play around with that. Okay, so the density of steel, for example, is approximately 7.84 grams per cubic centimeter. So that's the kind of the space between my fingers here. Okay, if I stop share, the space between my fingers. It's a little cube like that. It's like 7.84 grams. Okay, so that's pretty heavy. Steel is a heavy material. Okay, so when we, so steel is heavy. Okay, brass is actually even heavier. But there's some benefits to brass, and I'm going to kind of talk to you about them a little bit. Things you're going to want to think about. Okay, in other words, 1 cubic centimeter of steel would have a mass of 7.84 grams. Well, Mr. Dufresne, it doesn't say that. It says 0.00784. Well, that's because it's a cubic millimeter. A cubic millimeter is super tiny. Okay, so if you look at your ruler that I gave you, and you look at it, and you're looking at the metric side of it here, and from the 0, and you come in one little line, that is a cubic millimeter. From here to 1 is 1 cubic centimeter. Big difference in those, okay? But they are proportional, okay? All right, so so everything has different densities, okay, and different tensile strengths. You can look at Kevlar here, how light it is compared to brass, and it's very comparable in tensile strength, okay? So we can look at balsa wood has a density of 0.17 grams per cubic centimeter, and down here it lists it in cubic millimeters, which is 1/10 of a centimeter, so it's really super light. So you look at, since Newton's law tells us that decreasing mass will increase acceleration, then the lightest possible materials in a minimum volume must be the right way to go, right? Oh, no, not necessarily. Because generally lighter materials are not as strong as heavier materials. From our table, we can see that basswood is more than twice as heavy as balsa wood, but it also is more than twice as strong. So if you look at here, here's your basswood. And then this one here is almost twice as strong here. It's actually even a little bit more than that. Basswood is a lot stronger than balsa wood. So that's stuff you got to consider. For our sake, I'm going to tell you right now, balsa wood's probably where you want to go. When considering the axle selection, so We usually make our cars in class out of basswood, so if you want to make several runs, you may want to consider using basswood. Body design is not the only thing to consider when it comes to mass. The total mass of your car includes the mass of the wheels, axle, bearings, and the CO2 cartridge. When considering axle selection, for example, we can say that aluminum is always better, because we can look at aluminum here. Okay, that's light. Okay. Aluminum is always a better choice than brass because it's lighter. No, not necessarily. As we'll talk to you later about it. Brass axles may produce less surface friction than aluminum. So it's possible that a heavier axle will result in a faster car. Once again, we have an interesting trade-off to consider here. Okay. So center of mass. Center of mass is kind of where the center of your car is at. So I'm going to give you an example of center of mass right now. So if I stop this and I take my pencil here, and if I play here, see my pencil doesn't balance on my finger right there. But if I slide it over a little bit, a little bit more, oop, too much. Okay, there's my center of mass right there. Now, I can tell you that there's more pencil sticking out this end here than there is over here. So center of mass can vary on things all over the place. So it depends on where you're getting it to balance at, okay? So, and with this, I've got a heavy eraser and a piece of metal on the end of it, so that it'll shift that stuff off. Do the same thing here, and it's pretty close to center. You can see that it's shorter on this side here and longer over here. Okay, so all that stuff goes into effect, okay, with your car, and that can depend on a couple things. Okay. So that can depend on the distance from here to here, and this is like finding the center this way, and from the bottom of the car to the center of the car this way. So you have your X and your Y. Now, I don't want you to get all freaked out about the math in here, and this is essentially what I just did here with my pencil. I found the center point where I could get my pencil to balance evenly on my finger. And you would do the same thing with your CO2 car. It's a composite shape though, so it's a little harder to figure out. But this program in this here will do it for you. Okay, and they give you some math. The formulas are easier than they look. It's not a big deal, but you're going to want to come back and reread this whole thing here. Now, you also want to think about center of mass on cars. So if we look at like an SUV here and the Porsche here, which is a sports car, you can see that the center of mass is lower to the ground. Cars that have a higher center of mass tend to be a little more tippy. So this car going around a corner is going to hug a heck of a lot better than this car here because the center of mass is higher. Now, if you lower a car down, you bring the center of mass down lower, then it's easier to corner, okay? But we're running pretty much in straight lines, okay? So for us, what we're dealing with is stability, okay? Again, stability is how your car goes down the track. So the center of mass helps us understand how the object will behave when external forces are applied. In an automobile, and the center of mass is high, the vehicle will tend to flip when going around a corner. SUVs and vans will have a higher center of mass than sedans, which is why we sometimes hear about rollover problems with these vehicles. Good example would be a semi-truck. A semi-truck has a real high center of mass, and especially going over the narrowest bridge, and they got winds blowing, they usually shut the bridge down because they don't want the semi-trucks blowing over on their sides. Okay, race car designers try to keep the center of mass as low as possible, kind of like this Porsche right here. If the center of mass is located in the middle of the wheelbase, the car's mass will be evenly be split between the front and rear axles, resulting in better cornering. Likewise, the stability of a CO2 car depends on the location of the center of mass. Also important is the contact width of the car. A wider car is less likely to flip when raced. Again, there are trade-offs, as you will learn in the next section. The width of the car may affect forces that slow your vehicle, but nothing will slow your car down more than flipping it and sliding it down the track. Okay, so we can measure, we can use a measure called stability ratio. To evaluate the stability ratio of a dragster, the stability of a CO2 dragster is defined as the contact width of the car divided by the y-coordinate of the center of mass. The bigger the this value, the better. Okay. So the contact width of the car is the average width of the front and rear axle assemblies measured from the outside edge to the of the wheels. The following figures show that the front and the rear contact width of the car a rail car. Remember, the average of these numbers is established overall contact width. So generally, a good stability ratio will be equal to greater than 1.0. By definition, a ratio greater than 1.0 means that the contact width of the car is greater than the height or y-coordinate of the center of mass. Higher numbers represent more stable car designs, making them less likely to flip during a race. You're going to want to look at that, okay? All right. So today, if we look at my car, if I go file, oops, I gotta move this. Okay, so here's a car that I was making earlier. So I want to close this out here. And if I go to mass, I turn the eyeball on. Okay, here's my mass. If I turn my wrench on here, looky here, here's my stability ratio. So my stability ratio on this car right here is a 2.93. Okay, it's got a pretty high stability ratio. Here's my center of mass right here. So what I got to do is I got to apply, done. That turns out. So they show you different portions of it. So like this is the front wheel. That's the mass of the front wheels. So up here. So if I was to turn on my front wheels, turn on my rear wheels, okay. Now, my wheels, these wheels are got too much friction on them. I'm not going to use those down the road because it's just too much. So I can go to surface friction here. I can turn that on and you can see where all my friction is at. So at the back is the front axle bearing. I got a lot of friction there, but if I look at the rear axle bearing, that's what's shooting through the material here. Lots of friction, not good, okay? Go ahead and turn. It gives you all this information here. It tells you how much things are. Hey, I gotta knock some of this stuff out of here. Okay. So if I click done, that'll turn that off. Click this done, that turns off. All right. All right. So this is what I am going to do. I'm going to log out. And I am going to be checking to see who has logged in. So pretty important that you start logging in here and start doing this. I want to be honest with you. A lot of you haven't submitted stuff, and you know, you're going to have to do one of those 2 assignments that we did prior to this. And this one here will save your butt if you do it. But if you don't spend any time in here, which I can see, then it will, you know, you might not make it. So let's see, who do I have in here? That's not. Okay, so Carla hasn't logged in. Brooke, you haven't logged in since the 21st. Oscar, you have never logged in. You need to do so. Malachi has been in there today. Clint, you haven't logged in at all. Better go to that website that I put in the messages there. Mr. Joe, you also, Mr. Joe, you must get going on this. You haven't even logged in before. you are going to be lost, my friend, and it's not something you want to do. See, Edgar is logged in. Mr. Mejia, you haven't logged in since the 20th. David hasn't logged in since the 21st. Leslie's been in today. Carly says you haven't been in. Let me update this and let me see. Sometimes it does that. Oh, yeah, there you are. Okay, very good. Chris hasn't been in yet. Chris, you still can be working on this and doing good stuff. Let's see. Deshaun Rogers, Julio, you haven't logged in ever. Matt's never been here. Jimmy's in. Jaya, I'm hoping to see that change here in a moment. No, Jay hasn't been in yet today, but she was in yesterday, so that's good. Lan, you've never logged in. Alexandra, you've never logged in. So folks, you better get going here because this might be one of the few things that can help save you. It's fairly easy. You don't have to build, but you've got to spend some time. Okay. So let me go back in. I will recopy this to everyone. I will send it out again. So, for those of you that have never logged in, I'm going to take my time and I'm going to show you. So here we go. Pay attention, folks. And all of this is done in, if you go to Canvas and you log in, it's on the main page, on the part one of the CO2 car. Goes through all of that process and how to do it. But I'll show you again. Do not, so you go to that whiteboxlearning.com/login. You are not going to log in with Clever. Do not ever go to Clever. You're going to go to Dragster 2.0. You're going to type in your student ID number right here. Your actual Federal Way High School student ID number. That's going to go right there. And right here, you're going to go to HDZGU. And you click Login, and it takes you here. Okay? And you're going to want to click the Start button. And you have these tabs up here. You're going to want to read the engineering design process. You're going to want to read the design challenge. You're going to want to go over your inventory. You're going to want to go over the background and the background quiz. Those of you who have never even been in here, you're going to need to do Newton's second law, and you're going to do the motion quiz. Today I went over mass, and you'll need to go over the mass worksheet today. From there, you're going to go to engineering. And you're going to start working on your car. And this is where I'm going to tell you, you need to go and watch the video in part one of the CO2 car. Okay? All that information is there. Okay? You're going to click that and you're going to go to, you're going to follow along in that. Now, it is important that you go and watch those. Because if you don't take the time to watch it, you're not going to get anywhere. Okay? All right. Now,